Hello everyone, welcome to this session. In this session, I will explain Newton forward interpolation method and its Python code. Newton's forward interpolation formula is a method for approximating the value of a function at a point within a given set of data points, particularly when the data points are equally spaced. It utilizes forward differences to construct a polynomial that passes through the known data points. This formula is most effective for interpolating values near the beginning of the dataset. For example, the given datasets are the x values are given as 1, 3, 5, 7 and 9 and the corresponding f of x values are 1, 21, 65, 133 and 225. Find the value of f of x for x is equal to 6 using Newton forward interpolation formula. Please note that here the x values are equally spaced, but it is not necessary that the always x values should be equally spaced. Now the question is, when the x values are not equally spaced, then what to do? Then we will use another interpolation technique which is called Lagrange interpolation method. In my next session, I will explain Lagrange interpolation method, and in this session let's continue with Newton forward interpolation. Okay, here I have written some key concepts. Okay, and the first is equally spaced data. The method assumes that the independent variable, say x values, has a constant difference between consecutive points. And number two is forward differences. The formula relies on calculating forward differences, which are the differences between consecutive y values or the function values. And number three is polynomial approximation. The formula constructs a polynomial that matches the given data points, allowing for estimating of values at intermediate points. Next, I have written the forward differences. Okay, the differences say y1 minus y0 comma y2 minus y1 comma y3 minus y2 up to yn minus yn minus 1 when denoted by dy0 comma dy1 comma dy2 up to dyn minus 1 are respectively called the first forward differences. Thus, the first forward differences are delta yr is equal to yr plus 1 minus yr. The formula of Newton forward interpolation method is f of x is equal to f of x naught plus p into delta f of x naught plus p into p minus 1 divided by 2 factorial into del 2 f of x naught plus p into p minus 1 into p minus 2 divided by 3 factorial into del 3 f of x naught. And this is going on, okay, where f of x is the value of the function at point x and x naught is the first data point and p is equal to x minus x naught divided by h, where h is the spacing between the data points. And del f of x naught, del 2 f of x naught, del 3 f of x naught up to the forward differences of order 1, 2, 3, etc. and evaluated at x is equal to x naught. Here I have written the forward differences table. The first column is the x value, say x naught, which is the first value of the x values. Okay, and x1 is equal to x naught plus h, x2 is equal to x naught plus 2h, and x3 is equal to x naught plus 3h. x4 is equal to x naught plus 4h, x5 is equal to x naught plus 5h. These are the x values, and number 2 columns is the corresponding y values. Okay, the y values are say y0, y1, y2, y3, y4 and y5. From the y values, we calculate delta y, and delta y0 is equal to y1 minus y0, and delta y1 is equal to y2 minus y1. In this way, we also calculate the value of del y2, del y3 and del y4. The second column is del 2y, and from the value of del y0 and del y1 we calculate the value of del 2y0, that is del 2y0 is equal to del y1 minus del y0, and in this way we also calculate the values of del 2y1, del 2y2 and del 2y3, and the next column is del 3y, and we also calculate the values of del 3y0 from the values of del 2y0 and del 2y1, and del 3y0 is equal to del 2y1 minus del 2y0. In this way, we also calculate the values of del 3y1 and del 3y2 also. And the next column is del 4y, and by using del 3y0 and del 3y1, we also calculate the value of del 4y0. That is, del 4y0 is equal to del 3y1 minus del 3y0. In this way, we also calculate the value of del 4y1. And finally, we get the value of del 5y0, and the del 5y0 is equal to del 4y1 minus del 4y0. Okay, I think this is clear to you. Next, I have written some numerical problem based on Newton forward interpolation method. The first question says that the given data points are the x values are 1, 3, 5, 7 and 9, and the corresponding f of x values are say 1, 21, 65, 1, 33225, and write a Python code to find the value of f of x for x is equal to 6 using Newton forward interpolation formula, using all the points and using matplotlib. Plot the data points as f of x versus x and label them as original data. Also show the value of f of 6 as filled circle inside the same plot with a label test point. Find out the polynomial function for those data points using Lagrange interpolation polynomial from SciPy. Also plot the polynomial in the same graph and label it as SciPy interpolation. The second question are almost same. The second question says that the speed of a train running between two stations is measured at different distances from the starting station. If x is the distance in kilometer from the starting station, then Vx the speed in kilometer per hour of the station at the distance x is given by the following table. The x values are here is 0, 50, 100, 150 and 200. Please note that the x values are here are equally spaced and the spacing is here is 50, and the corresponding Vx, that means the speeds are 0, 60, 100, 120 and 80. And the question says that find the speed of the train at x is equal to 125 by using Newton's forward interpolation method, and plot position velocity data with matplotlib. Also show the interpolated point distinctly in the same graph and label the axis and write position velocity graph as legend inside the graph. The two questions are almost same. I hope that you will solve this question yourself after I will show you its Python code. So let's see its Python code. Okay. This is the Python code for Newton's forward interpolation method. Okay, as usual, at first I import some packages, say import numpy as np from scipy.interpolate, import Lagrange, and import matplotlib.pyplot as plt, and import math. Okay, then I return the question, the x values and y values which are given in the question, that is x values are 0, 50, 100, 150 and 200. Please note that here the x values are equally spaced and the y values, the corresponding y values are 0, 60, 100, 120 and 80. Then I enter the x inter p, that means x interpolation value, and I write it as x inter p is equal to float input enter the interpolation point. Okay, and then I have defined the forward difference table. So DEF forward difference table, here I have taken the name of the function as forward difference table and y is a variable. So DEF forward difference table y, n is equal to length of y, that means length of the y list, and the difference table is equal to np dot zeros in comma n. Here np dot zeros in comma n is a null matrix of n cross n is size. Okay, and difference table colon comma 0, that means the last column, I have taken the last column values as y, so I have written that difference table colon comma 0 is equal to y. Okay, and then I have write say this is a for loop. So for j in range 1 comma n and for I in range n minus j, difference table I comma j is equal to difference table I plus 1 j minus 1 and minus difference table I j minus 1, and then return difference table. In this way I have defined the difference table, and then difference Newton, then I have write the function Newton forward interpolation. Okay, so DEF Newton forward interpolation, here x values, y values and x are the arguments. Okay, so here I have written n is equal to length of x values, that means the length of the list, and h is equal to x values 1 minus y value 0, and you know this is the spacing. Okay, and difference table is equal to forward difference table and y values. Okay, this is I have taken it as difference table, and then calculate p. P is equal to x minus x values divided by h, that means x minus x naught divided by h, and then result is equal to y values 0, that means the first column of this list. Okay, and then interpolation p term, I have taken the first term as 1, and then I have written a for loop, that is for I in range 1 comma n, p term star is equal to p minus I minus 1, and result plus equal to p term into difference table 0 I divided by I factorial, and finally return result. In this way I have write the code for Newton forward interpolation method. Okay, and then I uh, I have solved this question by using scipy.interpolate.lagrange package. Okay, so I have defined another variable, say poly, that is poly is equal to Lagrange x vals comma y vals. This returns the polynomial. Okay, please note that this comment return the polynomial, and then I have also defined the x domain in, say x is equal to np dot linspace 0 comma 200 comma y100. Here 0 is the initial value and 200 is the final value, and 100 is the number of points in between 0 and 200. And here I have taken y another variable, and another variable y is equal to poly x. Okay, if you have any doubt in any uh, line, please print. Okay, so next, print the function if interpolation value at x is equal to x inter p is Newton forward interpolation x vals comma y vals. Okay, then print the polynomial is equal to Lagrange x vals comma y vals, and print the value of y at point x inter p by using SciPy, and the value is poly x inter p. And then I have plotted the polynomial and the x values and y values which are given in the question, and I have also plotted the interpolation point and the value of the function at the interpolation point. Okay, so I have written plt.plot x vals comma y vals and label it as original data which is given in the which is says in the question, and plt.plot x comma y and label it as SciPy polynomial, and plt.plot x inter p comma poly x inter p as label is at test point, and label the x-axis as plt dot x label x, and plt dot y label say f of x, and plt dot legend and plt dot grid for the rectangular grid, and then plt dot show for showing this plot. And I will run this code. Please wait a minute. And first it says that enter the interpolation point. The I take it the interpolation point, say 125, and just see that here please see that the interpolation value at x is equal to 125 is 144.025. This is by using Newton forward interpolation method. Okay, and print the polynomial by which I use the Lagrange function. Okay, and the polynomial is minus 2.667 x to the into 10 to the power minus 7 into x to the power 4, and minus x cube, and minus 0.01133 x square, and then 1.6 x. Okay, and the value of y at point x inter p by using SciPy, and you see the value is also 114.06. You see that these two values, that means the we get the values from Newton interpolation method, and also getting the value of it by using Lagrange function, and you see that that the two values are almost same. Okay, and here I have show you this graph. Please see that the here I label the x-axis as x and y-axis as f of x. Here the star points are the original data points which is given in the question, and the dotted line in blue color, that is the SciPy polynomial. Okay, this is the polynomial corresponding the data points, and the black circle shows you the test point. Okay, that is the interpolation point. This is, you see here, the interpolation point, I have taken the x values and 125, and the corresponding y values is nearly 114, and you see from the graph this is also nearly 114. You can also cross verify it that the at point x is equal to 125, the value is 114. Now see the data points. The data points are x values, when the x values are between 100 to 150, the y values are in between 100 to 120. That means when the x values is 125, the y value should be in between 100 to 120, and here I get the value of the x as at 125 is 114. This is the correct value. Okay, in this way you can check, and I hope that you will solve the another question yourself. Okay, I think this is clear to you, and thanks for watching this video.